Hi, I'm Tom D, and in this video I want to show you how to join two different indexes in Elasticsearch based on their GeoSpatial data using ESQL language. This is to create a crime map of the New York City. In this tutorial you use Elasticsearch and Kibana. Let's start. The first step is to start Elasticsearch cluster, both Elasticsearch and Kibana. On my blog, toughcoding.net, you can find the article with ready-to-use code snippets for this tutorial. On the screen you can see the QR code, you can scan it to get to that website, or you can use the link under the video. To start, first you need to create the network that will be used by both, the same network will be used by both Kibana and Elasticsearch node. Copy that command to create the network. Execute it in terminal. Network is created, you can check it, docker network ls, you can type grep okay, and you can see the network is there. Next, start Elasticsearch node. You can see these logs in Docker desktop that Elasticsearch is starting up. Now you have a command to reset the password, to set up the password for Elastic user. The password is 123456. Copy that command and execute it in terminal. You can see the response that password for the Elastic user successfully reset. Now we have 4 commands to execute that will generate the HTTP CA and Kibana token later used here when you start the Kibana. So please execute those 4 commands. You can check if the value is there by echo and Kibana token. Okay, there is a value, there is a token, means those commands were executed successfully. Now execute the command to start Kibana. Again, in the Docker desktop, you can see that Kibana is starting. You can see the message that Kibana is available. So you can go to the web browser and now you can log into the Kibana. Typing Elastic user and 123456 as a password. Here's an example queries in a console. You can clear them from the console. Elasticsearch is started, is up and running all together with Kibana. Let's go to the next step. Secondly, it's time to load test data. Here you can see the mapping definition as the first commands. Here, if you have currently running it multiple times, let's say you are doing some testing, first you can delete it, but because it's a fresh cluster, we can skip that part and go directly to this mapping creation. So please copy that 2 commands and execute them. Of course, you can copy everything. It doesn't matter, it will work fine. Basically, we see the error that index doesn't exist, but that's not the problem. Copy the first command, execute it in terminal. You can see that the index is created. And the second command to create another index mapping. So you can see the index is created, but it's empty, it's just a mapping definition. As you can see, it contains special fields here. Location is a geoshape for NYC neighborhood. And here for crime location, there is a geopoint, because neighborhood, of course, a polygon. It is an area that has some shape. You can visualize it on the map. Whereas the crime event is one GPS location. There is a data for that I prepared for you in IPFS network. There are 2 JSON files. One is containing like 600 lines, another is a smaller one. You can basically copy this as it is and execute it here. You can see that NYC neighborhood is downloaded and crime events is also there. If you check this file, you can see that it contained the bulk style, so it contained the index here, and it's empty because I'm not assigning ID, I'm relying on Elasticsearch. It will let Elasticsearch to create the ID auto-generated, which is faster because otherwise Elasticsearch checking if this particular value is not already in Elasticsearch. So if it's auto-generated, it's faster ingestion. And there are this data like polygon type of and coordinates, so which is the list of the points that will be connected together. So that's the data. Now time to load these files to Elasticsearch. So there are the cur command, which basically using this binary data this input JSON file. I'm redirecting this to the def null because you don't want to see this a lot of messages that will come to your console. Instead, you can redirect it to the def null, so you will not see this mess. Okay, both executed successfully, and now you can check in Kibana dev console if the data is loaded. Yeah, it's loaded. You can see these fields and they are not matching each other because the data is not merged right now. So you don't have, the points are not assigned to polygons, to areas, to the borough, because there's no join at this moment, which inviting us to the next step. Next step is to join these two datasets. So here you have enrich policy, which is the way to tell Elasticsearch to how to create the lookup table. Here it tells that please take the data from this index and the key field will be location. Look at this geo_match, which works on the GeoSpatial data. So here the location is type of geo shape because this is neighborhood. So this is geo shape. Based on that, it will match enrich fields. Then it will provide the neighborhood and borough as a response. So if you provide a point here, like geo point, like it was in the event crimes mapping, geo point, it will assign it to particular entry in the NYC neighborhood, to particular location, right? Because it will match on that field. And then it will gives you as a response enrich fields, which is neighborhood and borough. So therefore you can check at what area the crime happened by providing the GPS data of that crime event. So that's the policy. So let's execute it in the dev console. It's true. And secondly, you need to execute that policy. After the definition is created, you need to execute the policy. Status complete. So now we can see here using this ESQL query, you can see borough, you have location and neighborhood. So you have this lookup data that can be used later on. So now it's time to create the query. So the first query that you are going to execute it contains a list of crime type, time step, crime location, neighborhood, and borough. So you can see to the crime location, which is point from the crime events, you have assigned the neighborhood and borough, which is from the NYC_neighborhood index. So in this way, you join two tables, kind of. There are two indexes, not tables, but you can see that format is a text, which displays this result as a table. If you provide the JSON, it will look more like when you execute the DSL queries, but text format looks more like SQL table. Now the second query you can execute because you have this data you can aggregate. So you can create your some statistics. So here, when borough is not null, if you change it to the null, you can see that all data was matched. So there's no crime event that happened outside the New York City. So all these points that were in the test data are inside the New York City. So basically, to make it simple, you can remove this where clause, and it will give you exactly the same results. Here in the second query, you have a statistics. So you're counting and aggregating by borough and crime type. So you can see how in New York City, how many there are the assault, vandalism, robbery, and all the stuff splitted by the borough. If you remove the crime type, you can have it like this. Finally, it's time to do the visualization in Kibana. So go to the Kibana. Here in this search box, type maps. Click on this, and you have a map of the world. Zoom to the New York City here. Now you need to add the layers that will present the data on this map dashboard. Here, add layer, first layer. As a source, choose a ESQL language. Type query, first from. Now you can see there are already two indexes. First, let's add the NYC neighborhood. This will be the polygonal data to create these polygons showing borough and neighborhood. Okay, we need to keep location. And let's limit this to 1000, execute. Now you can save it and continue. If you scroll here to the layer style, you can change the color. Let's make it yellow, for example. Yellow color, and border can be black. Keep changes. So now you can see that this neighborhood data from NYC neighborhood, you can see that this contained 302 rows because it contained 302 polygons that are here visible on the map. Now it's time to add crime events to that map. Click on Add Layer and choose ESQL, like before. Now we need to change the index from, it will be crime events, and location to be crime location. Remember to run query. You can add and continue. And let's change the formatting, fill color to red and border color to white. Keep changes. It's done. As you can see, as I mentioned before, that none of these crime events happen outside of the borders of New York City, so you can see all of them are within this area. That's why you can create this aggregation and count how many crime events happen in a particular area. That's it. In this tutorial, we have learned how to join two different indexes based on their geospatial data. Like here you have polygons in one index, and in another you have points. So you can join the points to polygons. You can kind of assign the points to the polygons, and therefore you can present it on the map. You have also learned how to create such map here in the Kibana to nicely present the data. Thank you for watching that video, and remember to visit my blog. Here on the blog you will find the latest articles about the different technologies, including Elasticsearch. For example, this article, as you can see, contains ready-to-use code snippets, and that's the style of all the articles that will contain ready-to-use code snippet. You don't need to rewrite it, you can just copy and paste it and execute. And I'm encouraging you to have a look at the upcoming course. This is over 18 tips and tricks about Elasticsearch that I have used over last 10 years. It includes all the best practices and interesting tips and tricks that you can use for your projects. The release date will be announced soon, so stay tuned, and I hope you will like it. Have a nice coding, bye!